So we saw in the previous lecture that power law emerges, right? We observe power law in the network of wavelets, right, called the www graph, the web graph. We observed this, we saw this. Okay, now assume you have a network, right? So before going any further, I'm going to address this quick question on how to detect power law in given network. Assume you had a network, you're given a network and you have this question in mind. The question is this network exhibiting power law, right? If so, then what exactly is the exponent? So the x and y axis, and if you see something like this, what exactly is the exponent of this? I told you that the exponent in case of the web graph happens to be 1 over k square, right? So how will you find out whether your network that you are looking at exhibits power law or not? Okay, so here is a very easy litmus test that you all can quickly observe and sort of nod your head saying it's nothing but obvious. This is basically, as I told you, this is your f of x, rather f of k. If this is k, this becomes f of k, which is 1 over k square. So let me note that down. I'll say f of k is equal to 1 over k square. By the way, this exponent here needn't necessarily be 2. It is observed to be between 2 and 3. In case of some networks it is 3, in case of some networks it is 2, and so on, right? In some networks it is greater than 2 and less than 3, it is somewhere in the middle. Right? In any case, I would like to find out if a network is exhibiting power law or not. So how do I do that? It's fairly straightforward a process. If f of k is equal to 1 over, let's say, k to the power of alpha, for some alpha, I don't know what that alpha is, for some alpha, let's say, for some alpha. How do I find this? So I have a plot given. Remember, you can plot the distribution and you observe that it resembles something like this, and you know it is something like 1 over k to the alpha, but you don't know for sure whether it is a reciprocal of a polynomial like this k to the alpha or something. So what you do is, what is this curve? Observe this curve. This curve is nothing else but your f of k, and you ask this question, is it of the form 1 over k to the alpha? As you see, as the denominator increases, the value sort of decreases. That's why it becomes smaller, right? Okay, how do I see this? All right, so let me make some space for myself here. How do I see this? Let me write on this side. So how do I see this? Given that f of k is equal to 1 over k to the alpha, what I do is I apply log on both sides. Pretty straightforward math. I'm sure I'm not using anything beyond, let's say, high school level math, which is equal to log 1 minus log k to the alpha. So basics of logarithms, I'm sure all of you are familiar. This simply becomes log of f of k is equal to, we all know log of 1 is 0, right? So this becomes 0 minus log k to the alpha, alpha can be brought here, that's the property of logarithms, I'm sure you all remember, minus alpha times log of k. So look at this, So what does this mean? Log of f of k is equal to minus alpha times log of k. As you know, the x-axis is your k and y-axis was your f of k. Now you see, if you were to plot the log of it, Okay, so what you will do is you will plot instead of k you will plot log k, instead of f of k you will plot log of f of k. Okay, if you observe it, what do you see here? You see that, look, this is a variable, let me call it some y, which is equal to minus alpha. Please note this is a constant. Minus alpha is a constant because it's the power of k, right? K is the variable here, right? Times log of k, which I am going to replace by, let's say, variable x. So as you can see, you're getting a equation of a straight line, y equals minus alpha times x. So what does it mean? This simply means that when you are trying to plot the log of the graph, let's say you're not plotting the typical k and f of k, you're plotting, let me be clear here, I'm writing a plot here, it's my y-axis, this is my x-axis, and if I'm trying to plot, instead of k, I plot here log k, okay, and here I plot log of f of k. So what are we trying to say? Look at this. Look at this. I'm trying to say that this will actually be a straight line. Okay, a straight line, right? So actually it should pass through origin here, but don't worry, I'm just giving you an example. So this will be a straight line with slope, let's say, minus alpha. Okay, if you get a straight line with slope minus alpha, so let me write that down, a straight line, if you're getting a straight line, which means that log k versus log fk, rather log fk versus log k that you wrote was of this form, which means f of k was indeed of the form 1 over k to the power of something, and that something happens to be the slope of this line. So all in all, the litmus test is the following. It might sound very technical, but all I'm saying is the following. Let me write that down neatly. If one plots log of f of k in the y-axis, versus log k in my x-axis, just in case after plotting this, if you observe a straight line, then you can possibly conclude that there is power law happening here. Now you might ask me this question, when you are given a plot like this, let's say like this, why can't I observe this plot and then simply say there is power law happening here? But then this particular plot can be anything. It need not necessarily be 1 over k to the alpha. It can be anything, right? So you never know if it's really of the form 1 divided by a variable to the power of a constant, let's say alpha. You wouldn't know if it's like this only, right? So what you do is you instead don't take chances. When you get a curve like this, you try to draw the log plot. This is called the log plot. Y-axis make it log, x-axis make it log values, and then try to see. You will get a straight line, and when you get a straight line, it means that there's power law happening here. Okay, perfect.